Alright, so this is part 2. In part 1, I showed the actual mechanism of how the rest of this graph is going to go, get filled in. The alpha, basically the concept is alpha goes to beta. Alpha is your alpha carbon that's next to the double bond O, that, this carbon has some hydrogens here available. It's the most acidic that gets chosen for the alpha there. In part 1, I went through the mechanism, told you how to fill in this first one here. Now I'm just going to go through real fast, and I went ahead and filled in the rest of the graph, and so you can see that it's really not that hard. It looks really hard. It's really intimidating at first because stuff is huge, but it's not that bad. Find your alpha, find your beta, connect the two. Okay, so beta, alpha. I connected them. Whoops, here goes my chalk. Connected it. There you go. That methyl piece is coming off the alpha. Here's the methyl piece coming off the alpha. The alpha is connected to a double bond O and an OET. There we go. So it looks, this piece here looks just like this piece. And this piece here is this without the OET. Alpha, the next one, alpha goes to beta. This is the one that lost the ester, or the OET group, so it's gone. Since the OET group left, you take your alpha and connect it to the beta, and you connect everything that's connected to the alpha here. So this group here is this right here. Alpha, beta, alpha, beta, connect them, and that's your product. Again, alpha is usually is the negative there. Oh, and one thing to point out here too. This, you might say, well, why isn't this here the alpha? Because I just was saying that the alpha is in fact the one that has hydrogens available. Well, this has hydrogens available. This one has hydrogens available. This one has hydrogens available. Why am I not picking this one? You might think, well, this one has the most hydrogens, it's the one that's the most acidic to be chosen, but it's not. This is. And it's in between two double bond O groups. So it being in between two double bond O's, anytime you see that, choose that carbon in the middle to be the negative, your alpha, connect it to the beta, and boom, you have your product. The rest of it is self-explanatory. You got this group here that looks just like this, lost the OET group, alpha goes to the beta, you write what was attached to your alpha here. And again, same exact thing. There's nothing different that's happening in the whole entire thing that I can think of. So hopefully you can see all those products and the starting materials. It's happening in a base and its solvent, the acid. So that's what you need. You need to make a beta keto ester, you have mixed Claisen. The beta goes to the alpha. You do the mechanism and you write your product. So the best way is just to find your alpha, find your beta, connect the two, losing the OET group. It's always going to go away. And I guess that's it.